All right, so for this problem, we have a crane at the Hopper Hall building that is trying to lift a load. We're given the 18 kip upward force of the line that leads to the crane, and we're asked to find for the forces acting on the two rigging lines that's labeled RL1 and RL2. And we're also given the angles for those two lines. So this is a statics problem. We can tell that because we have three forces that are going to act in equilibrium to give a net force of 0 on our object. So we're given our free body diagram with our three forces. We can go ahead and we can define positive directions for x and y. So positive x is going to be the right, positive y is going to be up. This might seem pretty straightforward for this. This becomes more important when we start getting to moment problems later. So it's good to get in the habit of always defining which directions are going to be positive and negative. So that's what we're given. So we're asked to find the forces RL1 and RL2. And then so for our solution, since it's a statics problem, the way we're going to do these is we have three base equations for statics. We have the sum of the forces in the x direction is equal to 0, the sum of the forces in the y direction is equal to 0, and the sum of the moments about any point, which a moment is a distance times a force, is also equal to 0. So for these problems, we're always going to do these in the same way. That way, you have a straightforward process that you follow every single time, and that can be really helpful when you face new problems and you don't necessarily know exactly what the solution is going to look like. So the way I approach these is, first step is always create a sum of the forces in the x direction equation, and then you check to see if you have enough information to solve the problem. And then if you don't, do a sum of the forces in the y direction equation, and then do a sum of the moments equation. Now, once you get good at these, you might be able to tell right away which equations you're going to need to use and which you won't. But for now, when you don't have as much experience, it is good to get in a routine because, again, that'll help you if you don't see exactly where you're supposed to go. All right. So for our first one, we'll do our sum of the forces in the x direction equation. So sum of the forces in the x direction is equal to 0. So if we look at our three forces and our directions for x and y, we can see that our 18 kip force is straight up in the y direction only. So that's not going to be applicable to our equation for summing forces in the x direction. Now if we look at RL2, what we can see is we can see that it has a y component in the downward direction as well as an x component in the positive x direction. And then likewise, RL1 has an x component and a y component. So if you remember back to trigonometry, you can find the opposite side away from the angle using sine, right? So this side of that triangle is going to be RL2 times the sine of 20 degrees. Likewise, the x component of RL1 is going to end up being RL1 times the sine of 30 degrees. And then if you want the adjacent sides to those angles, again, trigonometry, RL2 cosine of 20 and RL1 cosine of 30. So I'm not going to go into this much detail on kind of breaking up into components on every problem just for now since it's the first one. That's kind of the process we're going to be using whenever we have to break up vectors. So if we look at our x components, we have RL2 times the sine of 20 degrees in the positive x direction, and then we have RL1 sine of 30 degrees in the negative x direction. So if we look at that equation, we have one equation and we have two unknowns, RL1 and RL2. So if you remember back to algebra, you can't solve two unknowns using one equation. So we're going to need a second equation. All right, so we move on to doing sum of the forces in the y direction. So for this, we can see we have 18 kips in the upward direction. And then in the downward direction, we have RL1 cosine of 30 and also RL2 cosine 20. So now we have two equations with two unknowns, equal number of equations and unknowns, so we can solve the problem. So there's a couple ways to do this. If you have your TI-36 calculator, you can use the numsolve function. Also, if you want to do it kind of the algebra way, you can separate out one of your equations and solve for one of your variables. So you get that RL2 is equal to RL1 times sine of 30 degrees over sine of 20 degrees. And then you can plug that into the, your sum of the forces in the y direction is equal to 0. So then you can plug that in for RL2 on your other equation. So you have 0 equals 18 minus RL1 cosine 30 minus, and then RL2 is equal to this expression. So RL1 sine 30 over sine 20 times cosine of 20. And then at that point, you have an equation with a single unknown. So you can plug that in and solve for RL1, and you get that RL1 is equal to 8.04 kips. And then once you have that, you can plug it into the other equation. So RL2 is equal to 8.04 kips times sine of 30 over sine of 20, which gives you that RL2 is equal to 11.75 kips. All right, and that's all you need to do. So this is your kind of most straightforward statics problem where you're given three forces, and you have to do a sum of the forces in the x direction and sum of the forces in the y direction. And then so that's how you get through these. Okay.